In the previous video in this series, I finished assembling the first part of the Curta calculator, and I'm going to move on in this video to assembling the carriage. Before I do that, I just want to respond to a comment that was made on the previous video. Very useful comment, quite helpful, and giving me some advice on various aspects of the operation of the calculator. But it made me realise that certain things I hadn't really touched on. There's things I'm going to be coming back to, but it might be better if I just touch on a few of those things now, just to make it clear what the overall purpose of this series will be. So, making a YouTube video, a series, especially on something as complex as the Curta calculator, is surprisingly difficult, and anyone that's made YouTube videos of this type will attest to that. It's what to include, what to leave out, and I don't want to make the videos too long-winded and boring for everyone. And you'll notice that the viewing figures for this series are already starting to plummet, so hopefully enough of you will stick around to make it worthwhile to continue the series. But the comment was about the alignment of the gear teeth on the stepper drum with the gear teeth on the input selector gears, and that the person was having difficulty getting them to align correctly. Now, one thing I haven't mentioned, I was going to come back to this in a later video, but I thought I'd just mention it now, that anyone that's watched any number of my videos will know that I generally don't take a single step approach to things. I'm very diligent in the way I go about engineering projects, and that's how I'm viewing this. It's an engineering project. I'm not just printing a lot of 3D parts, slapping them together and hoping that the calculator will work. So I am making changes as I'm going along where I need to. Now, with regard to the alignment of the gears, I did say in the previous video that on the first shaft I'd glued these two parts together, and I was going to come back to this in a later video, but I'll mention it now. You may notice these bearing plates, you probably can't see it, but they're not screwed all the way on. There's about a ½ mm gap, I don't know if you can see it, between the bearing plate and these bottom cover plates. Now, the reason for that is because I haven't finished aligning these shafts. Now, the point here is you need to get the gear that's been selected with this slider properly aligned with the stepper drum gear teeth. Now, on the first one, what I've done, you again probably can't see it, but this bottom bearing pin is all the way in, it's flush with the bottom of the bearing plate, because I have adjusted this. And the way I adjusted it was to machine, using an end mill, machine the internal shoulder on this digit wheel so that I can move this shaft up or down to put the gear that's been selected exactly in line with the gear on the stepper drum. And you can do it there, you can do it at the bottom, or you can shorten it at the top shoulder depending on how you need to move the gear around. But I'll come back to that later. It's easier to do this once the carriage is in place, because you can see it counting then. And then also it's got the proper load on the drive shaft. At the moment the shafts are pretty much floating, but the gears on the end do generate end thrust, so it's better to do that adjustment once the calculator is all together. As I say, I was going to come back to that later. I didn't want to overcomplicate the explanation of assembling this bit, but rest assured, I am testing everything thoroughly as I go. And in fact, let's put this bit down. The parts in here are not all the first generation. I have printed other versions. These are the versions that were in the STL files that I downloaded. That's not to say there's anything wrong with them, it's just different 3D printers work in different ways. So I have printed a number of different versions, usually very small changes of most of the parts, including the stepper drum. This is not the one I showed before that didn't print properly, that was a separate experiment. But what I'm doing is testing everything very thoroughly as I'm going along and making any changes to any parts where I feel it's going to work better. For example, the cantilever springs I mentioned in the previous video. So as I say, rest assured I am going through this as diligently as possible. If you got any advice, then by all means leave a comment, but just be aware I am doing an awful lot of testing on this. Okay, I'll get this out of the way and we'll start assembly of the carriage. So the operation and the function of the carriage is fairly straightforward. It really consists of two sets of digit indicators. One's an 11-digit indicator and one's a 6-digit counter indicator. And these, the 11 digits is for the result, and the 6 digits is a turns counter, and they're used to keep track of the result of the calculation and the number of iterations for the calculation. So the general operation of the carriage is, as I say, it's fairly straightforward. It's just independent digit wheels, and they each, or most of them, carry a little pin. So I've got one here that I've actually put the pin in so you can see it. So there's a pin. Hopefully you can see the pin sticking out just here, and that's used to depress, when necessary, the carry lever. So as the number wheel rotates from 9 and wraps around to 0, that pin presses down the carry lever for the following digit, and that's what causes the carry, the extra 1 to be added to the following digit. So that's, those pins require fairly careful alignment. I'll come back to that in a few minutes. But all the wheels, really, they're independent, they're not interlinked within the carriage, so it's a fairly straightforward carriage assembly as far as that's concerned. There are some complications. Firstly, the entire carriage can be rotated relative to the lower body. We've got a clearing mechanism to clear all these digits back to 0. So obviously if you want to clear the calculator, you need some mechanism for doing that. And the designer made some very clever choices with this carriage, in that the result indicator and the counter indicator can be cleared independently. You can clear either one or both at the same time, so it's quite clever. Now the numbers, of course, need to be attached to these wheels, so he generated these numbers. These are different from the ones on the input register, but they're fitted in the same way. Just make sure that they're properly aligned. So I've only done one because I do need to make sure it's aligned correctly before I do all the rest. And what I've done at the moment is assume that the 0 is in line with the center of the, if you like, the low section of the gears, because that's where it's going to stop turning when you clear it. But we'll check that once we get it partly assembled. The first thing I'm going to do is go through and fit all the pins. Now there are two different sorts of pins. You probably won't be able to see this, but I'll try and show it anyway. I can pick one up. There's these pins, and these are half pins, so half of the pin is only half a circle. You can see I haven't cleaned these up yet. And the other pins are full round pins, so they're completely round. And they need to go in specific gears. There's only two different types of these indicators, but you do need to get the right setup and make sure you have the right pins in the right number of the different types of gear. So I'm going to do that first. The only thing to bear in mind when you're doing this is that the depth to which you insert the pin is important. It needs to go in far enough so that it will actually hit the carry lever and push it down when it needs to. But it also needs to rotate inside this cover, so these sit here, and it needs to rotate. This will be right up against this this face. You need to make sure it will rotate inside this recess, otherwise it will jam up when it comes down here and it will hit this lip. So make sure that it's pushed in the right amount. For me, that was 3.5 millimeters, so I'm going to insert them all the same amount, and if I need to I can adjust them later. I'm not gluing them in, they're just the pins are slightly oversized, so they need sanding and filing down, and I'm doing that just enough to make them quite a tight fit inside the wheel. You don't want it too tight because these holes are very close to the outside, and if there's like one layer of PLA, so if you push them in too tight it will cause a bulge. Wish you could file it down, but I'd rather just try and avoid that. The holes do go all the way through, so it's quite easy to run a small drill through, and hopefully I can get these assembled fairly quickly, and then we can start actually putting the rest of the carriage together. I fitted all the pins to the digit wheels, and I made up a template so I could properly align the half pins. So the way I used this was to use the apex here of these two lines where they join, put the number wheels so that was visible through the pinhole, and then lined up the top line so it was visible halfway through the hole, and then I could use the other line as a guide for the flat section of the pin, and that guarantees that I'm getting them in there at the right angle. I push them in to what I think is the right depth, so 3.5 millimeters protruding. I think that's right. We'll check that when we get further into the assembly. I then ran a reamer through each of them and some 2500 grit paper, basically wrapped around a drill in the drill and spun it for a few seconds to polish up the inside of the hole. I used the drill to polish up the shafts that these sit on, and then I checked each one to make sure that it is free to rotate and they spin very nice and freely. I also checked to make sure that the cut out end of each of these shafts fits into the recesses on the underside of the cover, so these basically sit in here. So I've made sure that each one fits, and this just guarantees that the wheel is properly lined up with the center of each aperture. So I've done all that. These are now good to go. So the next thing I have to do is fit the clearing teeth, which are two of these, a spacer, and that fits in this slot, and basically you sandwich them together, push them into the slot, and it's just a very tight fit that holds them in place. So I'll do that off camera, and the function of this is when you rotate this clearing cover, the teeth engage with these teeth on the wheels and they spin round until they get to the position where there are no teeth. This stops turning, and at that point the number wheel is cleared. So I'll get these fitted and we'll carry on with the assembly. I fitted the clearing teeth to the cover. They're quite a nice tight fit. I believe they're properly aligned. So the manual says the next thing to do is fit the handle that goes onto this. So this is a pivoting handle that goes on here. I'm going to leave that off for now so it doesn't get in the way. I'll fit this later. So it's held in place. There's a couple of rivets that are glued in place, and this is able to pivot out of the way so you can fold it in. But I'm going to leave that off for now. It might get in the way. So we have a pin that fits into this hole, and then we have this. This is a stop device. So I mentioned earlier that you can clear each of the two numbers in the carriage separately. So in order to allow the user to determine when they've finished clearing one of the two numbers, there are two stop positions in the carriage. That's what these recesses are for. And this kind of rides around here and then pops into the hole when the correct point is reached. So this has a spring, sits inside this guide, and then the whole thing is pressed through this hole on the other side. There are then two pins that also go on the other side, and these are to locate what they call the spider gear. I should say at this point that I have made another modification, and I'll just explain what the modification is and why I've made it. So the easiest way to explain this is if I fit one of these. So these shafts just press into the holes. We then have the number wheels, and they fit on like this. Now these holes are to allow click stops for these wheels so they kind of pop into the correct location. So it's a similar sort of function to the springs on the carry levers. It makes sure that they go to the correct location and then stay there once they've been put there. So these gone to here, a ball is dropped into the hole, and I have reamed these holes out so they are the correct height, and then as you turn this, the ball pops down into the gap between the gear teeth, so it creates this kind of click stop. Now, one of the things I noticed is that when I printed the spider spring from the STL file and then tried pressing this down, I haven't tried assembling this entire thing yet. As I say, I've just been putting various parts together to see how they worked and if they worked the way they should. So with this pressed down, which is how it will be when the carriage is assembled, it works quite well, but I notice this is much stiffer than it needs to be. It kind of clicks into place alright, but especially when you're clearing the carriage, you'll be moving several of these at the same time, because the length of these means that you'll be spanning several of the number wheels simultaneously to clear them, and that means it will be quite tight. Also, this is driven by the gears that are on top of the section we've already assembled, so the less force it takes to rotate this, the better the machine will feel, the more smoothly it will rotate. So I printed another of these and modified it. So this now has only 1/4 of the spring force of the original. So when I turn it now, I don't know if you can kind of get the idea on the video, but it now turns quite nice and freely. It's probably still a little bit too stiff, to be honest, but if I turn it slightly and then release it, you can see that the gear does go into its correct location. It does with this one as well, but it's just with the original it's much harder to turn the wheel, so I'll try to do the same thing again. If I try and spin it, it's very difficult to turn. It does turn, but like I said, I've got a feeling that might make the entire machine very stiff to turn, so I'm going to go with this one. If it turns out we need more spring force, then we can see what's going on, but in the meantime I think this will give us a much better feel, so I'm going to go with the modified version. The change I made was just to make the fingers on the spring narrower, so these are something like 2.6 millimeters at their thickest point, and I've taken them down to 1.2 millimeters at their thickest point, so we'll see how that works out. So the next thing I'll do is get the pins and the plunger, at least the plunger guide, fitted, and then we can start assembling the entire carriage. I've fitted the stop pin, the position ident guide. I won't put the plunger in until later, because otherwise it will just pop out and I'll lose it. I've also fitted the 2 locating pins for the spider spring. The next thing I have to do is fit 17 of these, and these just press into these holes, and what we have to do is make sure that we fit these with the recess, the little cutout on the end, and that has to face upwards because that engages with the cover when the whole thing is put together, and that stops these moving around and also locates the entire thing centrally. So I'll get these fitted, and then we can start fitting the actual number wheels. Okay, that's all the axles fitted. I can now start fitting the actual wheels to the axles. I will need to tear this apart later on, of course, to fit the numbers to the wheels, but I need to make sure that I've got them properly aligned first. So I will go ahead and complete installation of all the wheels, and we'll finish assembling the carriage and see if it actually works. Now these fit in particular locations. There are essentially now 4 different versions of this. There's the ones without the second gear, some with a round pin, some with a half pin, and then there's the one with the second gear, and they all have half pins. And then of course there are ones that don't have any pin at all. So I'll get these fitted. I'll do it off camera, I won't bore you with watching that, and we'll go from there. So that's all the number wheels fitted onto their axles. Got to be careful now we don't let the whole thing fall apart. And now we just simply drop a ball into each of the recesses around the outside of the hub. As I say, these act as the click stops for each of the wheels, and there are 17 of these, so 11 digits on the results dial and 6 on the turns counter. So with all the balls in place, we should be able to fit the spider spring, and that engages with the 2 pins we fitted earlier, so that goes on there. Next thing we do is fit the cover. This is threaded around the outside, so this performs a number of functions as well as kind of being cosmetic. It also locates the end of each of the shafts for the number wheels, and then this threaded section allows us to screw it onto this part of the calculator, so it forms a complete unit. So in theory this should sit directly onto the ends of each of the shafts. I haven't tried fitting this yet. The silver section is for the turns counter, the black section is for the results dial, so we'll try and fit this, and fingers crossed it will fit into place. Which it does, so that's quite good. Okay, so the next thing I'm going to do is to screw this part of the carriage onto this part, and when you screw this down, this lip here presses on the end of each of the drive shafts, the curved section of the drive shaft, and holds the whole thing together. I'll need to do this off camera because it's going to be quite a fiddly operation, and I don't want this flying apart and all the parts disappearing around the room. So that's it screwed most of the way in. I'm not going to screw it all the way in, it's quite tight. I probably need to make a tool really. But it is screwed down far enough so the shafts are now captive. It's about 1 millimetre off being screwed all the way in, but it is quite tight and I don't want to risk damaging it, and we'll screw it all the way in when I do the final assembly. But the shafts are captive, so the centre part of the carriage won't rotate relative to this, which is part of the function of this cover. So that's looking promising. The next thing we have to do is fit the clearing cover itself, which is this part, and it should just drop down into this recess, which it does. And then the next thing, we take the hub. I'm just going to zoom you out a bit, you're in a bit close there. Okay, so I need to fit this pin before we put that cover in as part of the test. Now this spring I know is too long, so I'm going to need to shorten it. I'm not quite sure by how much, but the spring tension at the moment is too high. So I'm just going to take a few millimeters off the end of this spring and we'll try it again. Okay, we'll try that and see if it's any better. Again, this is one of those things that we'll have to experiment with to get the exact feel right. I'm just trying to get the pin to go through the little hole at the bottom of the guide, which is there. So I'm going to shorten it some more. So we'll try again. What I'm aiming for is to try and get the bottom of the wide section of this pin to be just inside the guide. So about another 2 millimeters and we should be about there. So we'll try that. Seems to be a good starting point. Make sure the spider spring is properly located, which it seems to be. And we can now try fitting this get the hub, thrust washer. This then goes down onto here. That fits through there, and then the nut fits on the underside of the centre. tightens all the way down to the shoulder. And this should, in theory, still turn, which it does, and we should also be able to turn it all the way, and it should clear all the numbers. Now we're not going to be able to see the numbers turning, of course, it's already done one of them, but there shouldn't be a huge amount of force required to turn this. So as I turn this, we should hear the numbers being cleared. Okay, I think the plunger is catching. I'm just going to take this back off. I'm going to try it without the plunger in place. I'm not sure why the location holes are as deep as they are. They seem to be way too deep, and I think the plunger is getting stuck down inside the holes. I think this plunger is getting stuck in these. Yeah, it's not going to come out of there. I'm not sure why they're so deep, so I might need to make another modified version of this. But we'll try it without the plunger in to start with and see if it allows it to turn freely, and if it does, we know what the problem is. So we'll try that again. I'm also going to try setting some numbers on some of these. I'm also going to try setting a number on that one so we can see if it is actually clearing, and let's try it again and see if it actually turns freely. And it does. Turns very nicely. It's a bit, I need to make this washer narrower. If I do the nut all the way up to the shoulder, it pinches it. But that's an easy modification. Just take half the mil off that thrust washer. We'll try turning it again. So I'll set a number on there. So we've got 6 set. I'll zoom you in so you can see it more clearly. Okay, now this would of course be a lot easier if we had this attached. It gives you far more leverage, but I don't want to rely on having leverage to turn this. If it's tight, then there's probably something wrong. So we'll try it again. We've got 6 on the only wheel with a number on it. We can hear the rest turning, and as I get to this point at the bottom, so normally to clear both numbers you rotate the clearing disc once. So when we get round to the bottom, the number's starting to turn, stops at 0. We're not quite in the right place with the digit. It needs to go a few degrees further to the right, but it's at least in the general right area. This will then go around and stop in the position indicated by this. But I need to modify this. Those dimples are way too deep, and this is going down into them, and then it can't make its way out. We could smooth the ramps a bit. In fact, I have filed them till they're fairly smooth, but they're just way too deep. They don't need to be that deep. But as you can see, this now turns very nice and freely. I'll just try setting a few of the numbers so there we won't be able to see it. They'll have random numbers set, and try clearing it again, and you can hear them clearing as we turn. This is taking almost no effort at all to turn this. It's just very light. And we're back round. Okay, so that's cleared the entire set. So that appears to be working really well. I'm quite pleased with that. As you can see, this is not screwed all the way down, which is why we've got a bit of a gap between the numbers and the cover. But the rest of it is working extremely well, so it looks like it's actually going to function the way it should. These take very little force to turn, so I don't think we'll have any issues with them being turned. These are turned by the gears that poke out of the top of the first section that we assembled. We can see the carry levers. They're what press the carry, or sorry, the carry pins. They're what press the carry levers down. These segments, by the way, allow the carriage to be put down in different locations so that the calculator can process different columns separately. So, as I said before, if you're multiplying 1,000 by 1,000, you don't need to crank this around 1,000 times. What you will do is crank it once for the units column, turn the carriage round, crank it again for the tens column, turn the carriage round, crank it for the hundreds, etc. So you crank it 4 times rather than 1,000. But that is looking very promising. I need to get this fixed on. I'll do that off camera. It's just really a case of putting the rivets in. So the first one goes like this, and then the second one goes into the second hole. These are glued in place, and this just gives you far more purchase. You can kind of just move it around like this rather than having to turn it by hand. As you can see, it needs a little bit of adjustment. It's a bit tight on this one, but yes, that's working very nicely. So in the next video I'll get this finished off, I'll get the numbers all fitted, and then in the next video what we can do is fit this to the calculator and see if the calculator actually works. So before we finish this video, I thought I'd give you some indication as to how freely this moves, so you can see what we're aiming for and what all the work's been for in trying to polish all the shafts and everything. So with the lever or the handle fitted, you can just very easily spin this round and it clears all the digits. So that's working very nicely. I'm actually quite surprised at how little force this takes. I was expecting it to be a bit more of a fight to get that to turn than that. So okay, that's it for this video. In the next one we'll actually see if the calculator can calculate. Okay, I'm not that mean. I thought I'd try fitting this and the carriage together and see what the result is and whether or not it seems to do what it's supposed to. So this just drops onto the bottom part that we assembled previously. So it sits on like this. I'll zoom you out so you can see the entire thing. Okay, so carriage is cleared, we've got a 0, we can't see the rest of the numbers of course, but if we try to rotate the calculator, then the number that's in the input should be transferred to the, because this is clear so it's got all zeros in. So if I try rotating the calculator, then it's difficult to do this. I'll try rotating this back to the home position. So you can see we now have a 4 in this location, and if we follow it down you can see we had a 4 selected on the input. So that appears as if it's going to work. It is transferring the numbers up to the carriage. So as I say, it's looking like we're going to end up with a calculator that may actually work. So in the next video we will get this fitted, and hopefully all the little niggles. I need to sort out the stop pin for this and try and get it to work correctly, and then I'll fit all the numbers to the number wheels on the results and the turns counter, and then we can try putting the retaining clip, the ident ball into the carriage itself, and then we'll put it through its paces and see if it can actually do any calculations at all.